students, today we are going to see semiconductor laser. First, we will try to understand what is semiconductor laser. And the semiconductor laser is very small in size and appearance. It is similar to a transistor. I hope you all saw transistor. It is very small transistor and has operation like light emitting diode, like light emitting diode. But here light emitting diode, this diode will emit only the light. But in laser, the output is in the form of laser beam, of particular monochromatic beam only emerges out of this semiconductor laser. So the output of this semiconductor laser has the characteristics of laser light. You all know what are the characteristics of laser light. One is monochromatic, second is coherent, highly directional. So these are certain few characteristics. So the output of the semiconductor laser is exactly laser, and it is having all the properties of the laser beam. The material which often used in semiconductor laser is the gallium, very important, gallium arsenide. This is very important. Semiconductor laser means the material used is gallium arsenide. Therefore, semiconductor laser is sometimes, or the other name of this is known as gallium arsenide laser. One more name it is there, very important. It is also known as injection laser. One is semiconductor laser, second is gallium arsenide laser, or third name is injection laser. Let us see the construction. We will draw. Sorry, कुछ ज़्यादा ही बड़ा हो गया. Now this is okay. Here you draw like this 3 lines. Similarly here also you draw 3 lines from here. This only particular region. Now this is, we will give dot dot dot. Connection like this. metal contact. This is partially reflecting, and this is partially reflecting, and from here light emission will take place. This is metal contact through which current is, the flow of the direction of the current is like this. It is coming inside. This face is highly reflecting, and this is depletion region. This is P and this is N. This is P type and this is N type. As we already know, when P and N, then there is a depletion region. This is partially reflecting surface, this is totally, and from here the light will emit, and this is the direction of laser beam. Ultimately light emission is nothing but laser beam will come out. This is the direction. Now this is the diagram of semiconductor laser, very important. Like this you need to draw, and the diode is extremely small. Its size is very small, with a side of order of 1 mm. The side is of the order of 1 mm, and the junction lies a horizontal place. So we will write everything. These two faces will constitute partially reflecting, totally reflecting, and this is the cavity, resonant cavity. We will write each thing. The diode is extremely small in size, with sides of the order of 1 mm. The junction lies in a horizontal plane through the center. The top and bottom faces are metallized, and ohmic contacts are provided to pass current through the diode. See here in the two faces below also metallic contact is established, and as a result the current can flow. Top and bottom face are metallized, and ohmic contact are provided. Ohmic contacts are provided to pass current through the diode. The front and rear faces are polished parallel to each other and perpendicular to the plane of the junction. This is the front, this is the back. These two faces are polished. One is partially polished and second is totally polished. When the portion where it is partially, through which the light will come out, and totally their total reflection will take place, and it is, these are like this, and this is perpendicular to, so this ohmic contact face is perpendicular to these two faces. The the polished faces constitute the resonator. The other two opposite faces are roughened. Rough means the surfaces are not smooth, it is rough, so they are made rough so that there are possibility that the laser beam will come in this direction, in from here to in your direction. So it is always better they will rough the surface from both the sides so that laser will come from this direction only. The two faces are roughened to stop the lasing action in a direction other than the main direction. So now we will quickly see how the laser is formed in semiconductor. So working, we will draw the diagram. Please make use of scale. Conduction band, valence band, this is for N type, this is for P type. Now here for N, conduction band is full, here for P means holes, valence band, and this is junction. Now try to understand. So there are two bands, one is conduction band and one is the valence band, and this is for N and this is for P. When it is in the forward bias mode, what will happen? Electrons from the N region and holes from the P region are injected into the junction. कहाँ पे इंजेक्ट होता है? जब it is forward bias तो ये दोनों जंक्शन में आ जाता है, इंजेक्ट हो जाता है. तो यहाँ देख रहे हैं इलेक्ट्रॉन्स आ गया और यहाँ पे होल्स आ गया. When electrons and holes are there, what will happen next में क्या होगा? They will recombine. So recombination will takes place. For small value of forward bias, the electron and holes recombine, bring about. जैसे ये recombine होगा तो यहाँ से रेडिएशन निकलना शुरू होगा. Okay, so radiation will come out. The electron hole recombine and the recombination will bring about spontaneous non-coherent emission of photons in all direction. But हमारे laser बनने के लिए हमें important some properties is, one is coherence होना चाहिए, second is monochromatic होना चाहिए, and in particular direction में ही निकलना चाहिए. So this is not this is simple light radiation will come out. So first is हमारा जो सेमीकंडक्टर लेज़र है इसे हम फॉरवर्ड बाइसिंग करेंगे. जैसे ही हम फॉरवर्ड बाइसिंग करेंगे, इलेक्ट्रॉन्स फ्रॉम द एन चैनल एंड होल्स फ्रॉम द पी चैनल. याद रखना, जब इलेक्ट्रॉन्स रहेगा तो कंडक्शन में रहेगा और होल्स यहाँ बैलेंस में रहेगा. दिस विल बी इंजेक्टेड. कहाँ इंजेक्ट होगा? जंक्शन में इंजेक्ट होगा. तो यहाँ इलेक्ट्रॉन्स आ गया है, यहाँ होल्स आ गया. ये दोनों की प्रॉपर्टी कि दे विल रिकम्बाइन. सो दे विल रिकम्बाइन एंड इन द रिकॉम्बिनेशन प्रोसेस ये कैसा होगा? स्पॉन्टेनियस होगा. नॉन कोहेरेंट एमिशन ऑफ फोटोन विल टेक्स प्लेस। यहाँ की जो फोटोन्स है वो कोहेरेंट नहीं रहेगा। सो यहाँ पे कोई लेजर अभी राइट नाउ इट इज नॉट मेकिंग। सो वी विल राइट दैट मच पोर्शन व्हेन द जंक्शन is forward biased, electrons from the N region and holes from the P region are injected into the junction region. This is how pumping action takes place in a PN junction semiconductor laser. For small values of forward bias, the electron holes recombine and the recombination brings about the spontaneous non-coherent emission of photons, a very important, in all direction. एट दिस स्टेज ये जो है इट इज सिंपल लाइट एमिटिंग डायोड का ही वर्किंग आया है। बट एज सुन एज द फॉरवर्ड बायस हम और इंक्रीज करेंगे, जैसे जैसे फॉरवर्ड अभी तो स्मॉलर फॉरवर्ड बायसिंग किए थे हमने और वोल्टेज बढ़ाया तो और फॉरवर्ड जैसे जैसे इसकी वैल्यू बढ़ते जाएंगी व्हाट विल हैपन, नंबर ऑफ इलेक्ट्रॉन्स बहुत सारा कहाँ पे पुश होगा, इंजेक्ट होगा इन द जंक्शन, मीनवाइल नंबर ऑफ होल्स यहाँ पे होंगे एंड एज ए रिजल्ट यहाँ पे वही रिकॉम्बिनेशन प्रोसेस ही होगा। बट ओनली थिंग इज नाउ नंबर ऑफ इलेक्ट्रॉन्स इन दिस जंक्शन इज मोर एंड एट द सेम टाइम नंबर ऑफ होल्स इन द जंक्शन इज मोर एज कंपेयर टू द ग्राउंड स्टेट। तो थोड़ा सा इमेजिन करो, पहले ग्राउंड स्टेट था, एन में जब ग्राउंड स्टेट रहेगा तो इलेक्ट्रॉन यहाँ पे रहेगा और जैसे ही मैंने फॉरवर्ड बायसिंग बढ़ा दी, बढ़ने में क्या हो गया, यहाँ के पूरे इलेक्ट्रॉन्स यहाँ चले गए एंड एज ए रिजल्ट यहाँ पे कम हो गया और यहाँ पे ज़्यादा हो गया जंक्शन में, यानी यहाँ पे पॉपुलेशन इन्वर्जन अचीव हो गया। एट द सेम टाइम यहाँ पे देखो दिस इज पी टाइप, पी मीन्स होल्स ज़्यादा होंगे, जैसे फॉरवर्ड बायसिंग बढ़ेंगी व्हाट विल हैपन, मोर नंबर ऑफ होल्स विल बी इंजेक्टेड इनटू द जंक्शन, एज ए रिजल्ट द नंबर ऑफ होल्स in this portion is more compared to the ground state and compared to the previous state and population inversion is achieved। जैसे population inversion achieve होगा, recombination nature है, electron है and holes है, means they will recombine, recombination में one photon will be given out and this is spontaneous emission। जैसे spontaneous emission होगा ये क्या करेगा, यहाँ से जो first light emit हुआ है बाकी atoms को भी recombine के लिए stimulate करेगा and in this process stimulated emission will takes place and laser will come out from only this direction and afterwards what will happen, जैसे ही forward biasing बढ़ती है हमें लेज़र यहाँ पे मिलता है। So I hope तुम्हें समझ में आ गया है। Now we will write the things at this stage. The junction act as light emitting diode as the forward bias is increased the intensity of light increases. But when the forward bias reaches to a threshold value, कहाँ पे threshold value, the carrier concentration in the junction region rises to a very high value. The junction region therefore attains a very high concentration of electrons in the conduction band, and at the same time a very high concentration of holes in the valence band. As a result, the upper energy level in the narrow junction region has a high electron population, whereas the lower energy levels in the region are vacant. Hole is nothing but vacancy, okay, vacant. Thereby giving rise to the conduction of population inversion in the region. This narrow region in which population inversion takes place is known as inversion region or active region. Very important, that narrow region where the population inversion takes place is called as either we call it as inversion region, or the second name for that is the active region. When recombination of electron hole pair take place between the conduction and valence bands, It gives spontaneous emission of photons. The photons moving in the junction stimulate the electrons in the conduction band to jump into the vacant states of the valence band and produce stimulated or induced photons. The induced photons further produce more photons by process of stimulated emission and thus produce coherent beam, giving rise to laser action. A monochromatic and highly directional beam of light is then emitted from the junction. So now this is all about semiconductor laser and its working. Now we will quickly see what are the applications of semiconductor laser. Semiconductor laser is well suited for interface with fiber optics. This is this thing you all know, fiber optics cable, communication. Second is smaller in size, exhibit high efficiency. It requires low power for operation. Next is its construction is very simple, and here we are not using any mirror. Thus, by polishing properly the laser, we can achieve what the mirror is used to give. So here there is no need of mirrors. Now we will see drawbacks of semiconductor laser. Due to relatively low power production. These lasers are not suited to many applications. Second is semiconductor laser is greatly dependent on temperature, yani upon changing in temperature its characteristics may change. So temperature, the temperature affects greatly the output of the laser. It affects the output of the laser. Thank you.